Hi, this is an example problem from Chapter 12 that has to do with temperature conversions. So we're familiar with Fahrenheit temperature here, but also we know of the Celsius scale as well. And there are two different scales to assign degrees of hot and cold temperatures to objects. And they're related. The size of a degree for the Celsius scale is larger than for the Fahrenheit scale. So you've got 180 degrees between two temperatures for Fahrenheit, whereas you have 100 degrees between freezing and boiling point of water for Celsius. So there's more degrees. It's a smaller unit than Celsius. Let's see how we can go ahead and use these for conversion. Here we have a thermogram, a map of temperature variations of the ocean surface. This is measured by measuring the electromagnetic radiation that comes off the ocean, the same way that they measure your temperature with your forehead nowadays. So in this case, we're asked, convert the temperature range delta T equals 10 degrees Celsius to a temperature range in Fahrenheit and in Kelvin. So a couple of things I want to point out here. This is a temperature range. This is the range between -5 and +5 degrees Celsius, right? So we need to convert a temperature range. And a temperature range, of course, is distinct from a single point value of temperature, such as, say, 5 degrees Celsius or something like that, right? All right, so we're going to go ahead again and let's look at this conversion factor from Celsius to Fahrenheit, and we'll go ahead and write that down. So here's the function that allows us to convert point values of the Celsius temperature to Fahrenheit temperature. And we're going to see that, in fact, to convert temperature range, it's going to be this factor that we're interested in. What this actually tells us is that the size of a single degree Celsius, so 1 degree Celsius, turns out that's equal to 9/5 degrees Fahrenheit. In other words, 9/5 is 1.8. So a single degree Celsius is equal to 1.8 degrees Fahrenheit. And we can show you how that works. So here's a delta T Fahrenheit. Remember that that is a difference between the temperature of, say, two different point values of the Fahrenheit scale. And if we want to go ahead and plug this in using the formula, let's go ahead and do that here. So TF2, that's going to be, if I go ahead and use the formula here, that would be a C2 value. And then I'll subtract the same conversion for a second one. And of course, this will be some other point temperature. Now we can see what's going to happen here as we subtract the 32 Fahrenheit from this 32 Fahrenheit. Those cancel out. And then we're going to have a factor common, 9/5, which we can factor out. And we're left with the difference of these two temperatures in Celsius, right? So we're going to end up with TC2 minus TC1. And of course, this whole thing is just the change in the Celsius temperature. That is the range. So 9/5, that's 1.8. And this is going to be our delta TC. And so altogether, a change in Celsius can be related to a temperature change, a range of temperature values in Fahrenheit with this equation. Let's go ahead and use that result to solve this. Okay, so to convert to a temperature range, starting with Celsius, we're going to take 1.8 degrees Fahrenheit for each degree Celsius, multiply by 10 degrees Celsius, and we see that we're going to get a range in Fahrenheit, which is equal to 18 degrees Fahrenheit. And that makes sense because remember there's a smaller size for the Fahrenheit scale, a degree, so you're going to have more degrees than you will Celsius for the same range. Let's check out for Kelvin and Celsius. Look at Kelvin and Celsius. There's no factor in front of the temperature for Celsius when converting to Kelvin. And in fact, if you look at the difference between two fixed points of temperature, it's 100 degrees Celsius. It's also 100 degrees Kelvin. That means that the size of a degree for Kelvin is the same as Celsius. And that makes it really easy to convert a temperature range from Celsius to Kelvin or vice versa. So the conversion factor here, it is 1 degree of Kelvin is the same as a degree of Celsius. And actually we don't put the degree symbol for Kelvin for some reason. So this is going to simply be 1 times delta T Celsius. And of course, if it's 10 degrees Celsius, it's also going to be 10 Kelvin, the same number of degrees.